So, welcome back to the ZKI Maze. This is volume 2, and we'll be talking about zkP2P, a convenient way to do on or off ramp to crypto. So, ZKI Maze spawned out of this thought that there's a lot of research that's ongoing with ZK, but they're hopefully at the end of the day being used by people in these applications and products. And ZKI Maze is this open discussion between Avi and myself and soon others to bridge that gap between research, products, and how we might interact with them. So here we go with volume 2.
Great. You want to get into the product itself? I guess maybe a good place to start is the motivation behind zkP2P. So it's interesting because I typically look at the name, like it has two words in it, ZK and P2P, and it kind of revolves around these two concepts. So I think from what I got reading the docs and using it is that it's kind of a faster and trust minimized way to transact with someone who you don't really know, but like transact in a P2, like a person to person way or peer to peer way instead of going through a trusted third party. And specifically, it's like a really good way to on ramp or off ramp without doing KYC with a centralized exchange who might have like a pretty tedious process for KYC. So yeah, it's interesting way to get into crypto by using US dollars and your existing financial infrastructure, such as Venmo or Wise or whatever platforms they support. Um,
Yeah, I think that's a good point.
yeah,
Yeah,
yeah, maybe
here's
like you just use it with Venmo, right? Maybe good. Like if you could describe like what was maybe like what did you feel while using it, how convenient it was versus your typical flow when you use Coinbase or some other exchange to get USDC from your USD.
yeah, yeah, that it was interesting to see what that really looks like. And so for the flow, the intention that I was looking to do is, all right, how do I onboard, how do I get money that I have not on, crypto, on Ethereum, on chain, so that I can do all of the different, related sort of transactions, or like DeFi space, or really just have access to, permissionlessly spend, like we know or are familiar with in crypto. How do you sort of get that from Web 2 into Web 3? So I have money on Venmo and I want to get it on chain. Or really, I want it to be the fastest way. So for Venmo, what this process looked like, that there is this sort of registration portion of it. So you you have your Venmo account, and you need to be able to prove that like you have an actual Venmo account that's associated, that you can like spend, transact, and kind of exist within this existing like Web 2 ecosystem. So how that works is that I go through the flow. I just put in an email onto like the zkP2P app. So, put in one of my emails and then go through the flow of actually like linking an associated Venmo with that. So, what you can do is it has like a series of emails associated. So, this is a Google account. So, I sign in, allow it to be able to view just particular like aspects of my email, so that it can prove that I have ownership or have like payments essentially related with Venmo, and it like mints this proof. So it's created an associated on-chain address with these sort of out of the box wallet accounts, and now I have an associated wallet, right, an associated address with an address that previously had nothing associated to it on chain. and then it mints this proof essentially that I have an ID within Venmo, and it just is able to like create a proof essentially with that. So to anyone else, you're not like just revealing openly like what your Venmo account is, but now I have the ability to essentially transact from Venmo. Now I have this link to like on chain, and then I wanted to transact. Essentially, I wanted to get, in this case, like a couple dollars on chain and see if it works, and I can essentially Venmo like someone else, and then they previously, I guess I'm getting ahead of kind of what we're getting into, but I was essentially able to Venmo someone else, and then that same amount is then sent to my wallet associated with this email. So essentially
And
from
it was pretty fast, right?
it was
It
very
was like,
fast. I was
uh,
surprised. It was, yeah, I mean, definitely under a minute. And I know that might sound slow in the context of some of the things that we're looking for, like even instant payments within the context of Venmo, but to be able to like, actually have access to that money, not to go down that like
yeah.
whole rabbit hole, but you instantly can
But
do
you
like,
essentially traded with somebody who you didn't know, right? And
yeah,
it's like you Venmo like somebody, a total stranger, and you got what you actually wanted uh, in your trade, which is like you send somebody like US dollars and you got your equal amount of USDC within 1 minute. So I think that's pretty great, right?
yeah, it was really interesting, and I guess you brought up the point of like what that flow might look like elsewhere. So like Venmo, something that it probably use being in the U.S. Maybe not on a day-to-day basis, but on a more consistent basis than payment or like wire transfers or these like big account
Mm-hmm.
transfers. And the alternative that I'm familiar with is maybe you have like a Coinbase account, right? So I have a Coinbase account. I link it with my bank account. I then can make deposits to Coinbase, which then allow me to transact on that exchange, right? And then if I want to get it on chain, I could then send that money from the centralized exchange to an associated wallet. So there's kind of like this three hop thing where it all goes through, well, it goes through my associated bank, it goes through then like Coinbase itself, and then it would eventually hopefully send on the other side to on chain. So the deposits, I know you can do like some things. I don't know the exact details of it, but sometimes it might take a couple of days for you to really be able to have access to those funds to be able to bring on chain.
Wow.
Like there's difference between maybe the I don't
And
want to.
if you're not already a Coinbase user, then you have to do the KYC, and that could
Yes,
take a long time, right?
exactly.
That's the most painful part for me because you need like I don't know so many documentations, and then somebody is going to verify it. Sometimes it's automatic. Otherwise, like they would say like we'll get back to you once the documents are verified, and that process is like I definitely don't like that process.
Hmm. Yeah, that's a great point. I mean, I'm going from the perspective of someone that already has gone through that and probably has
Mm,
forgotten the pain
yeah.
of onboarding. But you also brought up a great point is that there are also some places where maybe it's not even like available or the process looks different. So it could be more difficult to even KYC with Coinbase using as this as an example than in other countries, right? Is maybe the onboarding path is different, or maybe you just have less options as a whole. So like this zkP2P creates this sort of framework or protocol that you can do this. I like the term trust minimized on and off ramping, so it's faster, right? So
Yeah.
that's a great point too. Is yeah, you have to onboard first and go through that process too.
Yeah, maybe we should get into like some of the details of how ZK actually fits in here, uh, right? And what is the use of the email? I think you described like that you gave access to your Gmail client to
Hmm.
the app, so it could read your email, um, and that's yeah, I think because like you're kind of trusting the zkP2P app to not not send emails on your behalf, but like uh, that's like obviously you could even copy paste your email or like forward it to them, and I don't think it adds too much to the trust assumptions of the system.
Mm-hmm.
But yeah, I think what is interesting to me with all these emails in the flow is that DKIM signatures, which is domain key signatures created using the domain key of the sender, these signatures are like pretty commonplace. There was this fact that I just learned that there are like 350 billion emails sent every day, which has these signatures, and these signatures are created using the to and the from of email and the hash of the body. Uh, so an email is essentially like an attestation, right, in its own, because you're writing something and you're attaching your signature uh, from your domain key. So it kind of it's an attestation that you're making, and and if and we can use this attestation to prove things about various real world things. So in this case specifically, when Venmo sends you an email that they have deducted $2 from your account and sent it to like some person elsewhere, then you can generate a proof with this email, um, saying that uh, $2 has been deducted from Matt's account and sent to the stranger's account, and 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 verify that the email was sent by Venmo.com.
Mm-hmm.
And if this proof is valid, if this proof is can be verified on chain, then you can mint, you can claim the USDC that was logged into the zkP2P contract.
Yeah. Yeah, that's a great point. I guess maybe rewinding quickly too is there's this aspect, there's emails used a bunch for all these different services. It's almost sometimes used as a receipt, right? This sort of ledger,
Right.
like you can almost view it as like a personal ledger almost, where you have this receipt of different, particularly in the case of transactions, maybe purchase something with a credit card, or in this case, you Venmoed someone. The It's commonplace for a lot of these Web2 services to use email as this receipt of something happening. It's your log of what has happened. And like you're saying, you have this domain key. And correct me if I'm wrong, is it that when I would send an email, let's say Matt at gmail.com, I send it to Avi at gmail.com, that the it's like the Google certificate authority, something roughly like that. That's like the one that's going to be sending it over the
Yeah,
email.
yeah. So yeah, that's
I guess
correct.
who's
Actually,
signing it
it's the mail
essentially.
server. It's the mail server who signs it. So if you're using Gmail as your email provider, then it's the Gmail who will sign it for you. And maybe they are maintaining like key pairs for everyone, all of their users. I don't know what's going on under the hood there. But like if you have your own domain and you're having your own email server, then you can use your own key. So for instance, like I have this domain, virtualp.me, and I have like a mail server. Uh, so when I'm sending an email from that particular email address, you know, then I'm signing with my own key. But like that's an interesting point because like uh, when people send emails, they don't typically think that they are signing something.
Yeah.
Uh, it's because like everybody's kind of trusting Gmail that yeah, email was like when email as a protocol SMTP was created was like a P2P system, but like eventually it kind of became like everybody who uses email mostly uses through Outlook, Gmail, maybe a few others service providers. But yeah, but like if you're willing to run your own email server, then you can basically sign your emails with your own key. And I believe maybe a lot of the corporate um, services, brands, entities like Venmo.com or like yourbank.com or whatever. Uh, I think they probably run their own email servers, right? They're not going to trust Gmail or like they probably want to attest to whatever emails they're sending out. So in their case, like it kind of makes sense to use their own key, right?
Mm-hmm. Yeah, it brings up a question then. What would maybe be the as we talk about getting on this thread of like trust minimized, you're sort of piggybacking off of the already existing trust that you have that Venmo sent you the correct email, right? And then like,
Right.
Gmail then, is also facilitating this, but let's say more likely Venmo is the one that's like sort of signing that email because it's coming from the domain. What would happen if I didn't have a key? Like if I didn't have a signature over an email, could you just include anything essentially? Is it there's this like these signatures ask act as a way to sort of stamp like a test, like you said, like
Right.
so like what would happen if I
Yeah.
didn't have a signature on an email? Are we just opening ourselves to a whole attack vector?
Yeah. Yeah. Definitely. Because like our source of truth here is Venmo, right? If Venmo says that Matt has transferred money to the P2P counterparty, then it's true. If Venmo says Matt has not transferred money, then then it's not true. So we are kind of trusting Venmo. So it's like So yeah, the only way we can trust Venmo is when Venmo signs an email. Uh, because if they didn't sign like an email, then like yeah, then you cannot trust. Like anybody could have sent an email from Venmo.com. Maybe their keys are compromised. And yeah, if Venmo's keys are compromised, then like then like all this infrastructure will fall apart. But then that's on Venmo because yeah, we are assuming that we are already trusting Venmo.
Mm-hmm.
So signatures are critical here because the only way we can trust Venmo or any bank or any financial institution is when they're willing to attest something with their key.
Mm-hmm. Yeah, that key gets at the fact of like the closest way that you can have a source of truth, right? A form of like authenticity, or really in this case, right? Is like you have these public keys associated with Venmo that you would be able to also ensure that that is like correct. Like this looks correct, right? You have some publicly
Yeah.
accessible information that since we're Venmo servers work somewhere across the world, probably spread throughout the US as well. You need some way to be able to, you can't just have the Venmo CEO signing off on every single like email that's going out.
Yeah.
This is
Yeah.
exactly right. So it seems like maybe a separate topic for another day is all this like
This is
programmatic
another
signing.
this is another interesting thing about email is that it's quite brittle, right? If you think about like when you used zkP2P to send the person the 2 USD, the email that they sent you, they have to parse that email and then find in the text somewhere that you have sent like X amount of dollars, right? So it's like a
Yeah.
search in the text thing, which makes it a pretty brittle flow. Because what if Venmo changes their email template tomorrow and then it will break, and then they have to update the logic to search somewhere else. Maybe they have to update their regex matching
Mm-hmm.
logic. Uh, so in that sense, it's not really ideal to use email for this interface. Maybe ideally you should use like an API. If but like there aren't like many APIs which will openly give you this data. And emails are signed, but generally these HTTPS APIs, the payloads of that API is not signed. So it's kind of a trade-off, right? Emails are very text heavy. You need to parse the text, but they are signed. And APIs they are structured data, but they're generally not signed.
Mm-hmm.
Uh,
Mm-hmm.
so interesting trade-off space.
Yes. Yeah. Everything is trade-offs. That maybe gets us into a little bit more if we want to dive into the how this works and go under the hood. You started to talk about like these like DKIM signatures, right? That you're now well, you're also, there's a couple different pieces there. It's DKIM signatures. There's the parsing of these emails, some like regex to create the different circuit, right? The different circuits to even prove, hey, Venmo sent this amount of money to and from, is getting verified. So maybe we can go into the how zkP2P works.
Yeah, maybe we can like do an example, like Alice and Bob kind of example. Uh, you know, let's say Alice wants to onboard her. She wants to get like USDC, and she has USD in on Venmo. And let's say Bob uh, has USDC but wants to get out of system, wants USD. So like step by step, how this would work is Bob will send his USDC in a contract and wait for someone to come in and send them uh, the USD off chain. So let's say Bob wants 5 USD uh, off chain. So Bob will send 5 USDC to the contract, and uh, when Alice wants 5 USDC, what she will do is she would find like one of these orders in the contract that are ready to be fulfilled, and maybe she'll find the Bob's order, which is asking for 5 USD off chain, and what and it will have like Bob's Venmo address there, ID or whatever, and then Alice would send that 5 USD on Venmo to Bob, and at this point she will get an email from Venmo.com, which is signed and which would say that Alice has transferred 5 USD to Bob on this date, and all the email jargon that emails has, typical email that you receive from your bank or something. And then at this point, Alice can use this email, the email headers and the email body to create a ZK proof. Uh, and the proof will essentially validate that $5 was sent to the recipient. Like it validate the sender address. It will send check the the recipient address. It will check the amount, and it would verify the signature. And if all these assertions are true, then a proof would be generated. And this proof, and Alice could generate this proof locally on her computer or like whatever on her browser, and then can send it to a contract. And if the proof is verified on chain in a contract, then she could claim that 5 USDC that Bob put there initially when we begin the protocol. And that's how like both the parties were able to get whatever they wanted. Bob got his USD, and Alice got her USDC. So it looks pretty, when I spell it out, it sounds very elaborate, but like we went through the whole thing in 1 minute, so like it works.
Yes, it does work. Can confirm that. And yeah, to summarize, yeah, once you start peeling back essentially all the different layers, then you realize the complexity of the system. It also starts to reveal some of the more and more of the trust assumptions that you do have in a traditional, let's say, even on-ramping flow, or scale it to a lot of different maybe related like payments as a whole. So you realize the complexity when you're trying to have two untrusted individuals interact with each other. There's a lot of different parts of the stack, right? That you have to, each piece of it, you have to ensure that you sort of have this trust minimization aspect. So to summarize the sort of flow that you described, essentially you have like two parties in this, right? So peer to peer. And I liked your example before of looking back at maybe the like early the 2010s ish, when you had someone who had cash and they wanted Bitcoin, right? And someone had Bitcoin. Maybe you meet up with someone in person and you can pay them the cash and then they'll, send you the Bitcoin, right? Because the infrastructure was not there, right? To be able to do this
Yeah.
on now what we use is on ramping and off ramping, right? And essentially the person that would have the Bitcoin in this case would technically be off ramping, and the person who had the cash and wants the Bitcoin would be on ramping. And now zkP2P creates this framework where you can scale this. It's a protocol for these, trust minimized, like on, offboarding, and really faster, hopefully convenient on and offboarding. And how it works is that, yeah, peer-to-peer aspect. I guess getting into that is, you know, Alice to Bob, maybe I say Matt to Avi here. And if in the case that Avi has it on chain and wants to go off chain, and I have things off chain and want to go on chain, I just Venmo essentially. I get like matched roughly with Avi, and I'd Venmo, right? So the end result for Avi is now he has, let's say, $5 in his Venmo account, and then there's this sort of intermediary like deposit contract that you had where you had deposited $5 on chain before, and then by being able to have all the proofs of this, ledger of receipt of transactions, essentially the email that was sent from Venmo, you can prove that. So you can prove that I sent you money. So therefore, the deposited sort of escrow-ish contract can then be executed, and I can get the $5 onto my contract. So like you said, it does sound
Yeah.
more convoluted when you have to go through each of the steps, because it is difficult to really build these like trust minimized systems and scale that. But I think that touched on really kind of like the flow of how it works. And then we can also include an example of us actually going through this in the. We'll add this to the video as well as us actually going through the flow so you can see what it looks like.
Yeah, but one more thing that is interesting in this whole flow is that like it's a futurish thing. I've seen proposals from them where they want to move to zkTLS instead of email, because as we described that email has these weaknesses where the bank could change the template and then your whole flow would be broken. Uh, because your regex logic would be broken. So zkTLS, like we described zkTLS in volume 0, right? It's really interesting tool where you can use multi-party computation with a notary and then use that mechanism to trust somebody like Venmo or Wise or your bank or any financial institution, and can rebuild the same flow using zkTLS. So I think for future that would be an interesting thing to look out for,
Mm-hmm.
and how zkP2P leverages zkTLS in the future to make this more robust.
Mm-hmm. Yeah, it's a great point of the relying on the email is brittle. It's tough when you have to expect this is exactly how the information is going to look. Then if that gets changed, then these proofs are sort of broken, and then you got to recreate your regex circuits so that you can be able to handle that. So maybe being able to work
Yeah.
directly with like session data, like from something like zkTLS, would be able to have more, I guess, stable proofs essentially. Yeah, you can maybe work with the
Yeah.
data a little bit longer, hopefully.
Yeah. All
So,
right. I think we kind of described the zkP2P in a nutshell, at least.
yes, yeah, I think so. Maybe I guess so, like we want to do a quick summary as well. Some of like the takeaways, some of the high level points of, I guess starting from the fact of, yeah, it's if you want to like on and off ramp, um, going through and having to onboard into these existing systems can take a little bit of time. And instead, if you're able to maybe use systems that you've already like KYC'd through, you can speed up the process, essentially scaling these in-person untrusted setups that we described, where you do the coffee shop pay for Bitcoin, how do you create the framework where that can scale and it can enable participation by people who don't trust each other? And instead, you have the system that's self enforcing and ensures that when I expect to withdraw or onboard an off ramp, that it actually happens. So, um, I think you touched on some interesting pieces there
Yeah.
too of like, you know, being even familiar with the fact that everything's getting signed today on like with ZKIM signatures is, I don't think about it today, but it's interesting to have that mental model of like you're attesting to it, right? When I send an email, there are signatures that are
Yeah.
happening. So you have a sort of proof there, right? Or rather the ability to verify that. So I think it
Right.
begins to unravel a lot of different aspects of this. So we'll include as well a little example diagram or flow essentially of using this so it can be a little bit more tangible too. But yeah, that's zkP2P in a nutshell.
Yeah. That's cool.
Sweet. All right, and
All right.
until next time.